Math Analyzers, and welcome to your Chapter 3, Lesson 9 notes. And we're going to solve quadratic equations by factoring, and I am so excited because this is one of my favorite things to do, right? You got the zero product law, two things multiply together, the answer is zero, so one of those things has to have been zero. That's what the zero product law is saying, because anything times zero is zero, right? So if you have two different things that have multiplied together and the result is zero, or even three or four different things, that means somewhere along the way, something got multiplied by zero. And so what you can do to solve quadratic equations is you can factor them into their pieces, having them set equal to zero, and then you can see which piece was equal to zero. What would be the values of your variable that gave me those different zeros, right? Those different zero potentials. So that's what we do to solve quadratic equations by factoring. So this is kind of the most basic way to solve quadratic equations and what you did for the most part in Algebra 1, right? We did introduce the other ways, which we will go through in Chapter 6, solving by completing the square and quadratic formula, the ways that we can get irrational answers and imaginary answers. Okay, so those other ways that we can get these. But if a quadratic equation is factorable, this is actually the quickest way to go. Okay, so let's just take a peek at some pre-factored quadratic equations, or even cubics in some aspects, right? And we'll see that in a little bit. But I know that this is a quadratic equation because x times x would give me an x squared. I know that this is a quadratic equation because this x times x would give me an x squared. I know that this is a quadratic equation because 2x times x would give me a 2x squared. And so I know in each of these scenarios, I've got an x squared that has been factored into pieces. Okay, it's been factored into its pieces. And so what I call this step is the T-chart step, where you separate the pieces using a nice little T. Okay, so I do that horizontal line under my two factors. My vertical line separates my two factors. And inside the T-chart, I set each of my factors equal to zero. Okay, so now I've got two mini linear equations to finish solving. Over here, it's a nice easy one. Add 5 to both sides. I get x equals 5. Over here, a nice easy one. I subtract 1 from both sides. I get x equals negative 1. So that means that 5 and negative 1 are my answers. You do have to have your factor set equal to 0. So this other side does have to be equal to 0 for me to assume that these two pieces, or three pieces in this case, had multiplied together to give me a 0. And in B, I say three pieces, right? Because there are three factors here. 1, 2, 3. Now, in the case of 5, it is never going to equal 0. So the first thing we do is when we've got a GCF like this that's just a number, we just take that integer and set it not equal to 0. That number is never going to be where your 0 is. If there's not a variable in that spot, that's what you do, okay? So we're just saying that this is not going to yield us an answer. Here, x plus 3 equals 0, because there's a variable there. And here, x plus 4 equals 0. There's a variable there. Okay, so now what I do is subtract 3 from both sides. I get x equals negative 3. Subtract 4 from both sides here. I get x equals negative 4. Out of my three places where I had factors, 2 of them gave me answers for x. Okay. Oh, I wasn't putting my answers in French curly braces. I'm sorry. French curly braces. Sounds so fancy. That's what they are. Negative 1 and 5. Right here. Negative 4 and negative 3. Notice nothing else there, even though there's three spots where you could have had answers. The only ones are negative 3 and negative 4, or negative 4 and negative 3. Doesn't matter the order you put them in those French curly braces. This is an integer. It's not giving me an answer for x. Lastly, yes, each of these is a factor, and so one of them does have an x involved, right? So it is set equal to 0. Okay, so notice the difference. This did not have an x involved. This does have an x involved. You set it equal to 0. And same here, x plus 6 equals 0. Now, When there's a number times your x like this, you just divide both sides by that number. But the thing is, 0 divided by anything is still going to give me 0. So over here, x equals 0 is one of my two answers. And on the other side, subtract that 6 over x equals negative 6. So those are my two answers, and let me throw those in the French curly braces, negative 6, 0. I try in my French curly braces to go smallest to largest numerical order when I put my answers for my variable there, but you don't have to. Okay, that's not required. Just both or all three answers for your variable need to go in the French curly braces. Now you'll note that exercise 1 and exercise 2, these are pre-factored quadratics, okay? So I just went immediately into my T-chart phase. And same here, there's only two answers, right? This is just an integer, so it can't be equal to 0. So I know that's out. Okay, there's only two answers. Here, I set equal to 0, right? And then add 4 to both sides, so it's positive 4. There's one of my two choices. And then over here, I subtract 7 from both sides, so x equals negative 7 is my other choice. And what I can tell by looking at the binomials is, look, it's a negative 4 in the binomial. It's x equals 4 is the answer. It's a positive 7 in the binomial. It's an x equals negative 7 in the answer. That kind of helps me, all right? So that kind of helps me to make my determination just by looking at the binomials if I've just got those numbers, right? So if I've just got it being those numbers. Again, we've already been looking at factored pieces. Let's look at pieces where we have to do the factoring ourselves, which of course we've just been focusing in on, right? In lesson 6 and 7 and 8, I've been reteaching you how to factor, or new teaching you how to factor if factor by grouping, this was your first foray into it, right? So here we go. Here are some x squared polynomials, right? So quadratic polynomials set equal to 0. So I don't have to do the work of getting standard form equals 0, okay? I don't have to do any of the changing here. I can go straight into the factoring piece. And if I look, I think what are the factors of 10 that are going to add to give me a positive 7 in the middle? So that would be x plus 5 and x plus 2. Keep in mind that my bigger factor does still have the same sign as the middle. So does my other factor, because if the end term is positive, these will have the same sign and it will be the same as the middle. So now that I have those two factored pieces set equal to 0, one of them must be 0. So I do my little T-chart and I set them each equal to 0. I get x equals negative 5. And over here, x equals negative 2. So let me put that in my French curly braces, negative 5, comma, negative 2. There you go. How about in the middle? Well, that's dots, difference of two squares. So perfect square minus perfect square. That always factors the exact same way. Two binomials. Take the square root of the front term, put it in the fronts. The square root of x squared is x. Take the square root of the back term, put it in the backs. The square root of 25 is 5, and different signs between them. Now T-chart. So x minus 5 equals 0. I get x equals 5 as one of the two answers. And x plus 5 equals 0. I get x equals negative 5 as one of the two answers. So the way that I write this in my French curly braces is I put a nice plus and minus in front of my 5. So it's giving me that there are two completely different answers. They are both the positive and the negative 5. Okay. But because they were the same, base integer behind it, the same absolute value, that's why I can put the plus and minus in front. Now, last one is a GCF, right? So let me just trinomial to binomials. This is dots, difference of two squares. And this is GCF, greatest common factor. And what is the greatest common factor here? Well, between 3 and 15, they're both evenly divisible by 3. And between x squared and x, they're both evenly divisible by an x. So My leftover is going to go in this binomial here. I know it's a binomial 2 terms because my original polynomial was only 2 terms. 3x squared divided by 3x leaves me an x to the first, or just x. Negative 15x divided by 3x leaves me a negative 5. The x's cancel out to a 1, and 1 times negative 5 is still negative 5. Now I can t-chart that. So I get 3x equals 0, and I get x minus 5 equals 0. Well, again, over here, I divide both sides by 3. I get x equals 0 as one of my 2 answers. And over here, I add 5 to both sides. I get x equals 5 as my other of the 2 answers. So 0 and 5 are my 2 answers for that particular polynomial set equal to 0. So 3 different examples there. Just a quick reminder that the standard form of a quadratic equation is ax squared plus bx plus c equals 0. It just means that you put your x squared term first, then your number term, then your integer term equals 0, right? If you have those. You might not have this or this. You have to have this for a quadratic. And the reason we say that is because we have to have an x squared in order to have a quadratic, okay? Now, the key is that you need to have your quadratic equation in standard form, meaning the other side of the equal sign has to be 0 in order to factor and t-chart. So when we look at exercise 4, the first thing you should see is that this is a quadratic equation that is not yet equal to 0. So this garbage is out. And the reason that garbage has to be thrown out is because it was not equal to 0. Okay? This quadratic, this quad was not set equal to 0. That is garbage. Can't do anything with that. Okay? Again, it's all based on the zero product law. If you've got something, if you've got 2 pieces that have been multiplied together and their result is 0, then one of the 2 pieces was a 0. But you don't know that here. I've got these 2 pieces that multiplied together to give me 6. Well, one of the 2 pieces wasn't 0 then. And so because I can't use that law, then I can't do this factor and t-chart here. So instead, let's do it correctly. X squared minus x equals 6. Well, let's subtract 6 from both sides of the equal sign. Let's get that sucker set equal to 0, right? Am I right? Of course I am. It's me. So here we are, set equal to 0, right? Now we got to factor. What are the factors of 6 that will subtract to give me a negative 1? And that will be an x minus 3 and an x plus 2. The bigger factor between a 3 and a 2 is the 3. So the 3 has to have the same sign as the middle. So the 3 has to have the negative. Because my end term was negative, they are different signs. So I've already used the negative over here with the bigger term, or the bigger factor, excuse me. That leaves the other one to be the positive. Now set them each equal to 0. So your 2 mini linears, x minus 3 equals 0, x equals 3. X plus 2 equals 0, x equals negative 2. And again, kind of doing that based on, I don't have any numbers in front of my x here. So I can just look and I say, oh, that's a positive inside the parentheses, so my answer is going to be negative. Oh, this is a negative inside the parentheses, my answer is going to be positive. There you go. Negative 2 and 3 in my French curly braces. There we have it. One last consideration to be made. That would be exercise 5. X squared plus 5x minus 5 equals 3x plus 10. So first thing we'll do is get one side equal to 0. Now, I know you've heard me say this a bunch of times, and if you're one of my Algebra 1s that is now in math analysis, you have heard me say this 500 times. If your x squared is already positive, get everything to be with the x squared. So x squared plus 5x minus 5 equals 3x plus 10. Well, guess what? The positive x squared is over here. So we're going to move these two guys by opposites, and we're going to match them up with any like terms. So the negative 3x goes under the positive 5x, and the negative 10 goes under the negative 5. And so we've matched up vertically our like terms. And now we actually combine them as we bring them down to the next line. Nothing else like the x squared, bring it down. 5x minus 3x is a positive 2x. Negative 5 plus negative 10 is a negative 15. And bring down your equal sign and your 0. So now over here it says solve the equation using the zero product law. Oh, whatever. There's more room over here. I'll rewrite. Why not? So what are the factors of 15 that will subtract to give me a positive 2? That would be x plus 5 and x minus 3. And yet again, because it's always the case, the bigger factor has the same sign as the middle. Bigger factor is 5, has the same sign as the middle. The other factor is dependent on your n term. If your n term is negative, these will have different signs. So positive already taken care of. This has to be negative. Now, teacher. X plus 5 equals 0. So x equals negative 5. X minus 3 equals 0. So x equals 3. In my French curly braces, negative 5 and 3 are my answers. Okay. That's it, guys. That's what we're doing. This is review, so there's a lot more practice problems, but do feel free to ask me for help if you need help with the factoring at all. All right, I, at this point, assume, because I just retaught it, that you know how to factor by GCF, trinomial into binomial, difference of two squares, factor by grouping, and factor when the number in front of x squared is greater than 1. So I assume that at this point, 4 of those we did teach in Algebra 1. The factor by grouping is, might need a little help there. But if you need that, let me know. I'm more than happy to help you. You in-person peeps, when you're with me on your hybrid days, ask me the questions on this. You virtual peeps, you got my after school time, so 2:30 to 2:50. If you got a question, ask away. Okay? I shall be seeing you guys for the last piece of this chapter. I can't believe we're already at the end. All right. Have a great day.